Good day, everyone. We are starting today's tutorial based on indices. Actually, we are going to continue from where we stopped at indices. We've looked at in our last class. We've looked at the definition of indices, the laws that guide indices. There are several laws that guide indices. Now, after this, before we look at some examples, I need to let you know some things on indices, some hints apart from the word, the seven law of indices. Now we have notes. The first one, when we have x raised to power 1 over 2, it implies that square root of x raised to power 1. Because the sixth law of indices says that whenever we have a power of a fraction, the denominator will become a root. And 2 is the denominator. That was why we call it square root of x raised to power 1. Why the what? The numerator will still remain as the what? As the power. The denominator will become a root. Why the numerator will still remain as the what? As the power. The denominator here is 2. So that was why it becomes square root. So, and the numerator is known as what? 1. So, we are moving to the second one. So, whenever you say x raised to power 1 over 2, it's still same thing as square root of x raised to power 1. The second one, over figure 2, which says that x raised to power 2 all over 3 is equals to, don't forget, the denominator. The one below is known as the denominator. The one upper is known as what? Numerator. The denominator will become a root, which will now be called 3 roots, or we call it cube roots, 3 roots x raised to power 2. Some people call it cube roots x raised to power 2, which says that the denominator will become a root, while the numerator will still remain as the what? As the power of the what? Base. So we proceed with figure 3. We have, open bracket, a times b raised to power n. It's still the same thing as a raised to power n. It says a raised to power n times what? B raised to power n. That is, whenever the bases are multiplying each other, the power outside belongs to every base inside the what? The bracket. So which can also be implied as a raised to power n times b raised to power n can be implied as a raised to power n, b raised to power n. So we have this. Now we have Roman figure 4, which says that open bracket a all over b, close your bracket, all raised to power n. It's still the same thing as the power outside the what? Outside the bracket belongs to everything inside the bracket, which says a raised to power n all over b raised to power n. The power here belongs to both the b and the what? And the a. So the next thing, we have Roman figure 5, which says that when we have a open bracket a plus b plus or minus b, close your bracket, raised to power n, which means plus or minus b. Either it's plus or it's what? Minus. So it implies that it's not equals to a raised to power its power, nor b plus or minus b raised to power what? Its power. So that is, when we have a plus or minus b, close your bracket, raised to power n, it doesn't imply a raised to power n, b plus or minus b raised to power n. So, and I need to let you know something. In this sixth one, when we have a raised to power n divided by a raised to power n. You know, this is the second law of indices. It says that whenever we have the same base dividing each other, you take one of the base, which is when we have a raised to power n and a raised to power n. You take one of the base because they have the same base, but dividing each other. You take one of the base and you subtract the word, the power, which says n minus what? M. Now, this can also be written like this: a raised to power n divided by a raised to power m. You can also write it like this. That is a raised to power n times a raised to power minus n. Take note. That is, you know, this is division. Now, if you want to change this division to multiplication, it can be written times a raised to power. The power here will now be minus m. Or the seventh one, which says a raised to power n times a raised to power n. We can also write it like this. Is the first law of indices that says that whenever we have the same base multiplying each other, you take one of the base and you add up the power, which says what? What's the power here? N plus m. Or it can also be written like this: a raised to power n times a raised to power m. You can also write like this: a raised to power n. You make this multiplication sign to be what? Division. But when you are making this multiplication sign to be division, the power of this base a will change this from positive itself to what? Negative. It will now be a raised to power minus what? N. So we have a raised to power n divided by a raised to power minus n. So please don't forget to subscribe on our YouTube channel on Samson's Tutor. Follow us on Facebook. Follow us on Twitter. Follow us on Instagram and TikTok on Samson's Tutor. And don't forget, subscribe on our YouTube channel. Thank you and God bless you.